Hello everyone, my name is Daryl. I work as a software developer. In this video, you'll see how I naturally work through a LeetCode challenge. This is a problem that I'm seeing for the first time, and I'll explain myself as I work through it. My solution won't likely be the best or most efficient. It'll just be the one that I come up with first as I'm working through the problem. So this one is going to be another easy one on the LeetCode site. This one's called path sum. So given the root of a binary tree and an integer target sum, return true if the tree has a root to leaf path, so you're adding up all the values along the path equals target sum. A leaf is a node with no children. So to show an example here where the target sum is 22, and then they give you this tree node path and everything, and adding these values together is equal to 22, so it returns true. And this one, target sum is 5, and it's false because there's no root to leaf paths where that works. They can give you a blank one, the target sum being 0. Interesting that the answer is false. So if it's empty, there are no root to leaf paths. Okay, so the number of nodes is between 0 and 5,000. Each value can be between -1,000 and 1,000, and each target sum can be between -1,000 and 1,000. All right, so let's copy over the function. I already have tree node in here. So the first thing we want to do is cover that kind of validation case. So if root is null, return false. If root dot left is null, and root dot right is null, if root dot value is equal to the target sum, return true, else return false. And of course we'll be able to do that. That just makes it easier. So those are just kind of the base cases. Now we are going to end up needing our private function. And this is the one that we're going to recursively call. So we're going to say, we could just call it the same thing. I kind of want to call it as path sum still, but we're overloading the function, which is fine. So we have a node, which is a tree node, and then you're also going to pass it target sum, but you're also going to pass it current sum, because as we go down, we want to pass the current sum down to the children. So we'll want to make current sum here, and we're going to set it to root.val, and we'll just do if root.left is not null. We're going to make a quick result, and we'll set it by default equal to false. If the left node is available, then we'll set result equal to has path sum, but we're going to pass root in this case, target sum, and current sum. We'll need to make that var. And of course we need to make this return a boolean. If results, then return results. So basically I'm just saying if we check the left path and we do have the sum, we don't even need to check the right. We know we already have the correct answer. We'll just return true. I'll make it more explicit. Otherwise, let's check if the root.right is not null. If it's not, then actually we want to pass left, and we just check that it's not null, so that's fine. And we want to pass the right here, and we'll just return result. It'll either be true because of this, or it'll be false because it returned false. So once you actually get to a next node, first thing we want to do is set current sum is equal to, add on to it the current node dot value. Let's just make var results sum, or we'll make it results, and we'll make it equal to current sum plus the current value. Now we want to check if we're a leaf node. So if, let's do this. If both of those values from node are null, then we are a leaf node. If we are a leaf node, then we want to say if result is equal to target sum. Actually, we just need to return, we're just going to do this, just return this. So basically, if the result that we just got is equal to the target sum and we are at a leaf node, then return true all the way back up to the top. Otherwise, we're not a leaf node. So we need to keep continuing, and we're basically going to do this exact same thing. You see here. In this case, we want to, so if left is not null, we want to, we're actually going to return whatever the return value of this is. Actually, yeah, if the left's not null, we do need to do the same thing, actually. Found sum, set that equal to false, set that equal to that. If found sum, return true. Otherwise, then we can just return this. If, sorry, 1 second. If the right node is not null, then we can just return this. Otherwise, return false. And of course, this needs to be right. And I think that will work. So I'm going to go ahead and try this out. Okay, got a wrong answer. And this is, okay, this is basically going to be that exact path. We returned false. Oh, sorry, when we go here, we have to send in the results. Yeah, otherwise that won't work. All right, let's try it again. Okay, let's try submit. All right, it works. So apparently it's pretty good on the runtime, above average, and it's not that good on the memory. It's not that good on the memory probably because, like typically with the way I've been going through these, I'm using a recursive method. There might be a non-recursive method that would be better on memory. Recursion is typically not that good on memory. Or actually usually runtime, so. But it ended up being better than average at runtime. All right, so let's go ahead and go over the code real quick. I'll back those extra spaces out and get rid of that import. All right. So we have our function here as hasPathSum. This is the initial one that's being called. So initially, we're just going to check for the kind of like the base cases, the ones that we know we want to get rid of real quick. So if the root is null, just return false. And then we just check if the root node that we got passed is the only node in the path. Because it's already a leaf node essentially. You check if the root's value is equal to the target sum, and you just return that. So if it's equal, it'll return true. Otherwise, it'll return false. Then here we're going to start our current sum, which is the current root's value, the root node, and then our results we're setting to false. That's going to be what we use to kind of check through the left and the possible right node calls. So here we check if the left node is not null, then we're going to set result equal to hasPathSum, and I'll go over that in a second. But this is just going to go down the left side and see if we can get the sum through any of the leaf nodes. So if that returns true, then we're all going to go ahead and just return true, because why even check the right side if we already have our correct answer? Because it doesn't matter if it's on the left and on the right side or anything like that, just that there is a way. But if it's not, then we're going to continue, and we're going to check if the right node is not null. And if it is not null, then we're going to do the same thing, but we're just going to check the right side. And then regardless of whether or not this returns true or false, we're going to return result. So if the right side has the path, it'll be true, otherwise it'll be false. Let's go over has path sum. So in here, when I say let's go over has path sum, I mean I overloaded the method because I thought that name was still good and I liked it. All I added onto it, I changed this to node instead of root. This is still target sum, and then I just added current sum because as we're traversing down the tree, we need to pass what the current sum is so that we know if adding the current value to the previous summed values is going to be equal to our target sum or not. And this just returns a Boolean. So first we're going to set result equal to, and I actually could probably change the name of this, because usually I like to name result the thing that we're returning. In this case, I'm not actually returning it. But anyways, this is just the integer value that represents the previous sum plus the current value, value of the current node. So here we're checking if we have a leaf node. So we have the sum all the way up to the current node. If it is a leaf node, then we just return result is equal to target sum. So if we found a path, basically, then we're going to return true, otherwise it'll return false. If we're not on a leaf node, we create our found sum value here, variable. And I'm using this for a similar kind of pattern that I did up here where I don't check the right side if I don't need to. So we initially set it to false. Then if the left node of the node that we're at is not null, we just simply recursively run has path node on it and pass it the left node from this node, the same target sum, and the result, which in this case is going to be the current sum up through the node that we're at right now. And so if that returns true, we just return true. I know I could have said return found sum here, but just like I did up here, I wanted to explicitly state that I'm returning true because I feel like that's cleaner code and it just reads better. But if it's not, if we didn't find the sum there, then we just want to do the same thing that we did up here where we check the right side, and regardless of what that returns, true or false, we're just going to return it. But of course, we also need to add a return false here in case the right node is null. And basically, that's how it works. It'll just recursively call back out. If it ever gets a true, it'll kind of exit quickly and return true as the result. Otherwise, it'll go and check every single path recursively and return false all the way back up to the top. All right, so I hope that helped you guys out. Thanks for watching. Catch you guys next time.